Today I am presenting my parallel programming assignment based on the Langston and simulation using Java and JavaFX. The objective of the project is to be implement both sequential and parallel versions of Langston and compare their performance using multi-threading technology. So let's move to the overview. Langston and cellular automation simulation where ants move on the grid following simple rules. So if the ant lands on the white cell, it's turned right. The same time, if the ant lands on the black cell, it's turned left. So after turning, the ant flips the color of the cell and moves forward. So over time, complex patterns emerge from these simple rules. So let's come to ant class. So in ant class, the ant class represents the ant objective of the simulation. This class stores the x position, the same time y position, and the movement direction. So we can see the method such as turn left and turn right and move forward and control ant's behavior according to the plant's rules. So let's move to grid. So in the grid class manages the simulation environment. It stores cell states using concurrent cache map. So each cell can either be black or white. So the class contains methods such as isBlack, flipCell, and getCells. So these methods manage cell update during the simulation. Let's move to sequential simulation. So in here, the sequential simulation class implements the single thread version of the simulation. So the step method processes one ant at one time. So the simulation checks the current cell color, change the ant direction, flip the cell color and moves the ant forward. So it should be done from here. So let's move to parallel simulation. In this coding, the parallel simulation class implements the multi-threading using executor service. So executor service create the thread pool and distribute an operation across multiple CPU cores. Each ant movement is submitted as a separate task using executed submit. So to avoid the race condition, synchronized block and concurrent cache map are used ensure thread safe access to share grid data. At the same time, let's move to simulation UI. On this class, the simulation UI class manages the graphical user interface using JavaFX. So it displays the simulation grid and movement arms and UI control. So I can show if you see from here in the bottom, you can see control buttons like start, resume, reset, its speed slider, benchmark. So were added to improve the user interface. So at the same time, the demonstration of UI controls. The UI includes several controls to manage the simulation. So the start button begins the simulation and fuse temporary stop execution. The resume continue the simulation. The reset clear the grid. So the speed slider dynamically change the simulation speed during the runtime. So the benchmark label display execution time while the steps label shows the total simulation step. Let's gonna have a look on performance tester class. So in here, performance testing was conducted to the compare sequential and parallel execution times. The system.nano time was used to measure execution performance. So the results demonstrate that the parallel implementation execute faster than sequential implementation when handling the large number of ants and simulation steps. Thank you.